This is the fourth video in section 3-2, and in this video I just wanted to clarify certain things from the empirical rule and the range rule of thumb, and then do one or two example problems as well. So the videos on empirical rule and range rule of thumb that I had prior was some recordings I did prior, and some verbiage or vocabulary used there was different and it's been updated. So I just want to make this video to just kind of clean things up. Okay, so empirical rule, I wanted to explain things a little further. So we know that we need to remember these three percentages, right? 68, 95, 99.7. And the importance was it states that approximately 68% of data values are within one standard deviation, 95% within two standard deviation, 99.7% within three standard deviations of the mean. Okay, so I wanted you guys to develop this picture in your brain as well. So let's say we have a normal distribution or a bell-shaped distribution. Each tick mark is one standard deviation. So we have the middle value here being the mean, and each of these is a standard deviation apart, right? So if we break it up like this, we know that the empirical rule says in the middle here, there's 68%, right? 68% of the values. So if we split that section into two parts, then we know that each of these is 34%, right? So 34% plus 34%, this middle chunk here is 68%. And then we know that from here to here is 95%, right? According to the empirical rule for bell-shaped distribution. So we can figure out this section here, what percentage this section represents and what percentage this section represents as well. And the way we do that is we would do the following. So we would take the 95%, right? Because we know that this entire thing from here to here is 95%. And we would subtract, so 95, and then we would subtract this middle chunk, which is 68%. And this 27% would be this chunk plus this chunk, right? So because it's been split into equal halves, we just need to take that 27 and split it into two. And that tells us that each of these sections, this section and this section, is 13.5. Sorry, I actually pressed the enter to get this. I did not mean to do that. So let's go ahead and clear that out. So we would get 13.5 and 13.5. So very similarly, we know that from here to here, right? So from three standard deviations out to the left and three standard deviations out to the right, according to the empirical rule, that's 99.7%. So very similarly, we can figure out this chunk right here and the other one on the right side by doing 99.7 and subtracting that middle chunk that we know. So we know that from here to here, this whole thing is 95%. So we're going to subtract 95%, and that tells us that from this part and this part, the remaining is 4.7. So likewise, we can divide it by 2 to figure out how much each of these guys are, and it happens to be 2.35%. Okay, so now that's not it. We still have these little tells here, these small area here as well. So to figure those out, we can do the same idea. We can use the same concept. So we know that under the entire curve is 100%. So we can go 100% minus 99.7, which is the, let's try that again. 100 minus 99.7, and we notice that we get that the middle, the tell ends, right? This tell and this tell combined is the remaining 0.3%. So if we divide by 2, we get that this part right here is 0.15%, and this part right here is 0.15%. So you add up all these percentages, you should get 100%. And also, if you cut this in the middle like this, right? If you add up these parts, you should get 50%, right? Because it's symmetric. Okay, so having that on hand, let's go ahead and work out some of these problems in the notes here. So we have, it says IQ scores have a bell-shaped distribution, so then we can apply the empirical rule, right? With a mean of 100 and a standard deviation of 15. And so using the empirical rule, we're going to answer these questions. So here's what I would do. So I know that the partition of the distribution, this bell-shaped distribution, has those percentages according to the empirical rule. And again, empirical rule are approximations, so these are approximate percentages. So we know that the mean is the middle value, right, in a bell-shaped distribution. And if each of these tick marks is a value of, is a standard deviation apart, they would be a distance of 15 apart, right? So from 100 going to the right, we're adding 15, so we get 115, and we get 130, and then 145, right? I'm just adding 15 to each consecutive number to get the next one. And then going from the middle to the left, this would be 85, right? 100 minus 15 is 85. And then minus 15 again would give us 70. And then minus 15 again would give us 55. Okay, so fill out the chart just like this. Fill out the values just like that. And now we can start to answer the questions. So for example, the question here says, what percentage of IQ scores are between 70 and 130? So between 70 and 130, we would just take a look at that chunk right there. That's between 70 and 130. And we can add those percentages. So if you add those percentages, you would get 95, right? So you added those percentages that's in the highlighted part that I just highlighted, you'd get 95. Or alternatively, if you notice that it's 2 standard deviations out to the right and 2 standard deviations out to the left, you know that the empirical rule says that's going to be approximately 95%, right? Question B, I'll let you guys work that one out. Question C, likewise, I'll let you guys work that one out. Question D, what percentage of IQ scores are below 115? So what percentage of the IQ scores are below 115? So here's 115. Below 115 would be the percentages are to the left like that. Okay, so all we have to do there is add up the percentages, but we can be a little bit smart about this. And instead of adding all these percentages, we can look at this and say, if we cut this right from here to the left, that's 50%. So that's going to be 50 plus 34, right? Which would give us 84%. Just a little small shortcut. And then the next question, let's go ahead and take a look at it. It says, what percentage of IQ scores are above 130? Well, here's 130, and above 130, the percentages above 130 are the ones right here, right? So this is the population. This chunk and that chunk represents the population which have an IQ score of above 130. So that's going to be 0.35 plus 0.15, and that's going to be 2.5%. Question F, I'm going to let you guys do that one by yourself. You can pause the videos if you want, and then check all my notes to see if you got the actual answers correct, right? Okay, the next one, which IQ score separates the bottom 97.5%? Okay, so the bottom 97.5%. So the bottom percentages are those on the left, right? These are the bottom percentages. And the bottom 97.5% would be the following. So this is like the bottom, if you add these two values up, these two percentages, this is the bottom 2.5%. And if you go further and you take a look at like this chunk right here, this chunk that I highlighted, this is the bottom 50%, right? So we're just kind of accumulating the percentages until we get to, until we see what the bottom 97.5% is. So we know that's the bottom 50%. Let's add this one to it. Do we get to 97.5? No, we don't, because 50 plus 34 is the bottom 84%. So we're not quite there. Let's add this section one more time. Or let's add that section to it. And do we get that? So let's see. We get 84. Turn this on. So 84 plus 13.5. And there it is. That takes us to, that gives us the 97.5% we're looking at. And the IQ score that separates the bottom 97.5 of the percent of the population is 130. So the answer here would be 130. And let's take a look at question H. So question H says, which IQ score separates the top 50%? So in this case, we're looking at the top, right? So the top are these guys on the right. And we're just going to start adding until we get to 50%. And this one's not hard. We know that in the middle, that's where it separates the bottom 50% from the top 50%. So the answer there would just be 100. And I'll just go ahead and do I just to finish it off. So IQ score that separates the top 16%. So again, now we're talking about the top, and we know that the top percentages are on the right. So we're just going to keep adding these percentages, these top percentages, until we find the top 16%. And sure enough, we get to that. When we add those three percentages, we get to the top 16%. And the IQ score that separates the top 15% is 115. Okay, so that's one application of the empirical rule. So in this section, I'm not going to ask you like a question where I'm saying like what percentage of IQ score is between like 90 and 105 or something like that, where the numbers aren't the ones that are on these tick marks. Right now, we're just looking at approximations, and whatever values I specify is going to be values that's on these tick marks. Later on in the semester in Chapter 6, we are going to look at situations where we can figure out like the top, we can figure we're dealing with values that's not on these tick marks. So when we get to that, we'll get to that. All right, so the other thing that I wanted to cover in this video was in the video on the range rule of thumb, I had used the verbiage unusually high, unusually low. The updated textbook, which is the one that I use now, I actually like the terminology that they updated with better, is they, instead of using unusually high and unusually low, they use the words significantly low or significantly high. And I like that verbiage more because it's more consistent, or not significant, because it's more consistent with what we're going to see later on in the semester. So that's pretty much what I wanted to do with this video. Actually, let me go ahead and do a problem on the range rule of thumb while we're at it. So again, significantly low values are values which are 2 standard deviations below the mean or lower. And then significantly high are 2 standard deviations above the mean or higher. That's what this is saying, right? So let's go ahead and take a look at an example. Let's look at this example right here. So this example says the mean and standard deviation wait time for the checkout lines of a supermarket are given as, so the mean checkout time is 5 minutes, and then the standard deviation is 2. According to the range rule of thumb, would the following wait time be significant? So with 2 minutes, waiting just 2 minutes, would that be significant? What about 10 minutes? What about 0.5 minutes? Right? So using the range rule of thumb, what you're going to do is you're going to figure out those values which separates the significant values from the ones which are not significant. So if we're going to look at a number line, we know that in the middle here, so the number line here represents the minutes, number of minutes for the wait time, and the average is 5, and each standard deviation is 2. So we know that the significantly low values are the mean minus 2 standard deviations or lower, right? And then the significantly high values are the mean plus 2 standard deviation or higher. Okay, so there's a couple ways we can do this. It's easier for most students to view this as, okay, it's 2 standard deviations to the right. I'm just going to jump 1, 2 standard deviations, where each of these is plus 2, right? 1 standard deviation is 2. So that would mean that the cutoff point for significantly high is 9 minutes or higher. So 9 minutes or higher, that's significantly high, right? And then likewise, do 1, 2 to the left, right? Subtract 2, and we end up at 1 minute. So most students find subtracting and adding like that easier, but you have to be comfortable with using these formulas as well, or that expression. So to find that 1 and that 9, we could use that formula. So for the 1, we can do the mean minus 2 standard deviation, right? So that's going to be 5 minus 2 times 2, because the standard deviation is 2, right? This 2 right here is built into the formula, so that one doesn't change. But this 2 was because the standard deviation is 2, and this 5 was because the mean was 5. So those two things change, but the 2 here is built into the formula. So that would give us, let's see, this is 4, right? And then that's 5 minus 4, which gives us 1. So similarly, if we plug it in here, so that'd be for the significantly high, that's going to be 5 plus 2 times 2. So 2 times 2 is 4 plus 5. That's going to give us 9. So be comfortable with using these formulas. So now this picture, what this picture gives us is we know that from 9 to the right, that's going to be sig high, significantly high. And then from 1 to the left, that's going to be sig low. And everything in the middle, right? Any wait time in the middle would be sig or not significant, right? So it would be not sig. Okay, so now that allows us to answer the question. So is 2 minutes, waiting 2 minutes significant according to the range rule of thumb if the average wait time or the mean wait time is 5 with a standard deviation of 2? So it would not be, because here would be 2, and it's not in the sig low or sig high values or range. So this is not sig. 10 minutes would be over here, which would be considered significantly high. 0.5 minutes, half a minute, would be right here, which would be considered sig low. Okay, so hopefully that helped. Again, if you have any questions, let me know and shoot me an email.